different definitions exist, different views exist of what an embedded system is. And this is one. It's a combination of hardware, software, plus it's hardware and software plus a set of mechanical. You have lots of boards and all that. So you have lots of peripheral devices also, keypads and things like that. So all that technology components or technical components designed to perform usually a dedicated task, a dedicated job. That's what we call as embedded system. Basic definition, any book you pick, you'll find this or something like this. Okay? But what we need to understand, this session especially, we need to break that barrier of academic books and look into the practically usage areas. We need to look into practical aspects of these softwares and hardwares. Right? So we'll do a complete out-of-box look at it. So these are few segments. As a student, first step, if you're building up career, the first step that you need to know is embedded simply does not mean ovens or devices like traffic control, railway control and so on. The different segments, the whole embedded technology exists, it is categorized into different segments, different usage and application areas. So these are a broad range of application areas that we have today. Companies are doing lots of investments and lots of work is happening to create new areas. Okay, so lots of new markets are evolving as a result of these investments. As a developer, step one is we need to know what's our target area. You may work with a company that's doing this kind of work, or you could find a job with a company that's doing this kind of work, or you could do a job with a company that's doing this kind of work. What's most important is each of these, when you want to pursue a career in embedded, then each of these have different set of skills required. That's usually missed. Generally in academic level, what is not known is if you want to enter telecom, the kind of learning you need to do, the kind of technologies you need to master are different. If you want to get into automation or electronics in automation, automotive electronics, then the kind of learning you need to do, the kind of areas you need to focus on are different. All of them are different in different issues, technology issues, software issues and hardware issues. Okay, so these are the areas. If you want, you can list down and take down those areas. Of this, which is a growing area? Which of the areas you think today has lots of growth? Consumer electronics. Why do you say that? You can find a lot of growth in that. Which of the sectors you are finding a visible growth, increased growth? Telecom. Telecom, medical. Okay, medical. So all the sectors are doing well, but if you look at the last 20 years or the last 15 years of what all investments have gone in and all that, massive growth, massive investments, and massively market is increasing in two of these. One is the telecom market, which is increasing enormously with these handheld devices and smart devices. The second is the consumer electronic. Daily we see a new vertical product getting added. We didn't have the so-called iPads or tablets all these days. Now we have a new segment now called a tablet PC. Like this, every day you see a new product coming into this particular area. So these are two areas where visibly lots of investments are happening. Lots of companies are working in that particular area. And obviously, job market also, if you're competing for jobs, you'll find lots of jobs in this. Sony recruiting or LG recruiting, Samsung recruiting, all that is because of this. Alright? There are few companies involved. It doesn't mean that all these are not being used. These exist. The market share for them is still there. There are few companies building these kind of products. But heavy investments and large of market is increasing in this area just because these are used by the end users. Okay, so it's a very big market. So these are the areas that we need to know. A little look at those investments. These are the facts. So if you look at this, the consumer electronics and intelligent homes, or basically consumer electronics, you can see a huge bar, lots of investments happening there, lots of jobs being created there, lots of work happening there. Followed by this telecommunications, mobile sector, lots of investments are happening, 4G networks and 3G networks are evolving, lots of embedded devices are being used there, routers, different kinds of switches and so on. So you have that next. Followed by the rest of them. The automotive industry also is doing well these days. These days, most of the cars are more expensive because of the onboard computers than the steel that is used to build them, right? So because of that, you find lots of market in this area also. In the coming days, you'll find a lot of entertainment devices as part of these automobiles. So most of them using Android. Android is also going to come up into those areas. So this is simple, a small stat of where the market is going. Market today is dominated mostly by consumer electronics. Why this we need to know? We need to know this because before you go to a job interview, you need to know what kind of company it is and what they do. From that, you can actually anticipate what kind of questions and what kind of technology they'll be interested in. Okay, as a student, or if you're pursuing a career, you need to know these things. This is a very old stat. I could not get the latest figures or not the old ones. By 2004, very old. You can easily double up this now in 2010. If you look at the whole market now, consumer electronics, 41.7% share, total investments. Lots of money being invested there. Lots of work is happening. This many billions of dollars, billions of euros. This was in 2004. Now this could have been doubled by this time with these tablets and all this coming. Okay. Then we have the next thing is military aerospace, followed by the rest of them. So like this you have lots of money being invested, lots of jobs being created in those areas. These are simple stats. These presentations will be given out at the end of these sessions. Presentations will be released to download. So far this is how it worked out. Now, if you compare the legacy embedded, we used to think, or still we think, that embedded means a single task. Embedded means a specific device that is used for a specific task. But it's changing. You can easily identify that if you notice any of the consumer electronic device. They are no more expected to be single task, isn't it? Driving these changes are two forces, which we need to easily identify. The first force is called technology push. Technology push is where new processors are coming up, new architectures are coming up, memory is becoming cheaper, unlike past. In past we had expensive memory, expensive processor, all that, isn't it? Now process speeds have gone up, they have become cheaper, memory has become cheaper, on the whole the hardware has become cheaper. And the users are expecting new features. Not just new features, users are expecting one device to perform multiple functionalities. Okay, so one is a market demand, expectation from the users. Second is technology being made available quickly at cheaper cost. These are two major factors which will drive technology forward. We had the 8051s, we had those DSPs. The old embedded development mostly was hardware centric. When I say hardware centric, if something has to be achieved, they used to take an application specific processor for that and then just write a piece of C code to give instructions to it. And processor would do majority of the work and software simply gives instructions to it. Okay, that's how it was, completely hardware dominated. So in those days, the software developer's job simply was to know about which processor is writing code for and write some instructions in assembly, cross-compile them, downtime and run it like 8051. But now because of these changes, the whole set of the way we work has changed. Okay, so these are two major changes or two major forces which are pushing technology forward. And this has been happening for the last 20 years in the embedded segment alone. Lots of changes have been happening. In all those domains, in all these areas, you find these two things changing the whole landscape. Now these are the new expectations. As a result of those changes, as a result of these changes, as a result of this technology being changed, expectations changing, These are new challenges for a software or a product developer who is into embedded. The first change is earlier embedded devices were not expected to be connected. We didn't expect them to be part of a network and do some kind of exchange of data on a network. Today we see every device, even a refrigerator, we expect it to be network connected. And soon you'll see every device, including the television sets, will have a YouTube connection, will have a network connection, accessing the internet and then downloading movies or videos, whatever you want, and playing them. So we have lots of connectivity need today. Everything and anything is to be connected, which wasn't the case earlier. When we say connectivity, what is required? How to achieve that connectivity with the network? We require protocols. We require hardware that can send data and receive data. On a PC today, if you want to browse web, you need some protocols to be there as part of your kernel or operating system, isn't it? You need all those hardware devices like Ethernet cards or Wi-Fi cards to send data and receive data. You need some driver components which can drive those hardware devices, isn't it? So that is first becoming a necessity. It's not a need, it's a necessity now on the embedded, most of the embedded devices. Second, convergence. When we say convergence, what we mean basically is multiple functionalities. A mobile phone today is not expected just to perform a mobile phone job. It is expected to develop as a camera. It is expected to develop as some other functionalities, isn't it? So we are expecting now multiple functionalities into one device. Okay, lots of that is happening in many sectors. Consumer electronics, you can see that visibly. In other industries, you need to be there, you need to look at those devices to understand this. Even in medical, you have lots of devices doing multiple jobs these days. The reason why vendors are pushing it is simply because of those two forces that we have seen earlier. Okay, it will reduce cost, it will give the customer more benefits, isn't it? So that's the second major change, major challenge. You need to now design those products which have multiple functionalities into them. Okay. The third one is power management. Because everything is becoming connected, everything is offering multiple functionalities. How do we keep it powered on is a challenge now. We're coming up with lots of different kinds of batteries which can stay longer, isn't it? Now battery power is there, the hardware is there. But how do you design your software to switch off those hardware components which are not in use right now? Say for instance, your mobile phone. If that mobile phone is designed to switch off a video chip when video is not being played, then you can save power. You can increase the battery backup, isn't it? When a particular net connection is not being used, a browser is not running, maybe switch off GPRS and all the GPRS circuit, isn't it? So you need effective power management. Power management is not just hardware. It's all about writing code and writing programs or writing services which will do this all the time. Okay? So that's the third need or third challenge. The fourth challenge, as everything becomes connected, everything becomes more prone for attacks. Especially with the smartphones today, if you look at smartphones or if you look at the medical devices, if everything is connected, there is a possibility of viruses creeping in from the network and then attacking that device and be stealing some data, personal data, or destroying the device functionality. So we need the device to be, especially embedded devices are expected to be completely reliable and secure. And sometimes device going down is not tolerable, isn't it? So that's the fourth challenge that we need to meet. All these weren't there earlier simply because devices were not of that sort. They were simply single-use devices. Okay. Now we expect flexibility. What is flexibility?
It can be operatable with every person.
Okay. Any other views? Maybe I'm going a little fast, but if I'm going faster, you can stop me. If you have any confusion in any of these, you can let me know. These are the major factors. These are the major factors. This will at the end tell you what skills you need if you want to compete for jobs in this area, if you want to edge in this area. That's the reason why we are looking at all this. Because what you learn should be directly relevant to what is being used. Otherwise, it's no use. Yes, what do you mean by flexibility? Today, vendors are not looking at designing a product and then throwing it to market and then supporting it or not supporting it. There is the story. Next product. That's not the way that development is happening these days. Development today is happening in such a way that The vendor expects whatever effort I'm putting to build up this product, whatever solutions I gain, say software solution or a hardware solution, I should be able to take that and adapt it to next product. So reusability is something that's becoming a major issue now, because cost going into one product R&D should be useful for other products also. We have versioning in the products. You can see the iPads and iPhones, so many versions of them. Now, Apple didn't work from scratch for every product, every version of iPhone. They've taken the same base code, they've taken the same base hardware, done some improvements to it, adapted it to a new version. So most of vendors are looking at this. So they're looking at using softwares which are flexible, using the embedded system and producing one more product out of it. So reusability kind of thing. Okay, that's the flexibility. Next, the intelligent devices. We want devices to be more intelligent, to interact with the environment, sensors and all that. You can see these Apple iPhones or any of these Android phones if you're using. You have devices, you have applications like monitoring blood pressure, monitoring blood sugar and all that. These applications are driven using camera, basic cell phone camera. All you need to do is place your finger at the camera, run the application on the Android phone. It will detect your finger, and from the fingerprint it will detect your blood pressure, heartbeat rate, and then blood sugar. So these kind of things are happening. So lots of intelligence is being added to this. This intelligence comes with algorithms. It's not just basic software. Lots of algorithms run for this to work. Okay. So those kind of things. Many other examples you can think of. Lots of intelligent devices we see these days. The escalators that you see, when a human being is on it, a sensor detects it and the escalator is on. Otherwise it's off. Okay. So we have localization, intonation. What is this? Can you think of what that is? Okay. Is there a need that mobile phone should have a interface in local language? Is that need today there? Is it being expected? Yes or no? Yes. If you have Google Maps, how better it would be if a phone can show Google Maps of locations in Hyderabad, isn't it? Instead of showing locations in US. The phone could be manufactured in US, produced by a US vendor. But if it can provide you local information, if it can interact with you in local language, device is more usable. The vendor can sell that. So we have localization, local fonts, local languages, the interfaces of the embedded devices being designed for that. Instead of the user learning to be how to use the product, let the product be designed to be more user interactive. Okay? So local products should become international, international products should be adaptable to local needs. It's all about providing multiple language interfaces. Most of our operating systems and PCs are doing this these days. Your Windows 7 with multiple language interface. You have the browsers with multiple language interface, Google with multiple language interface. So these kind of things also are required now with the interactive devices in the embedded stream. Non-interactive, we're not worried about this. And the last one, you see heavy use of graphics, 3D technology, animation technology, display technology is coming into embedded. Embedded devices, most of them in the consumer electronics were not meant to show rich graphics and rich animations. But suddenly now, because of burst of these products, we have lots of 3D technology being used, lots of display technologies being used within the embedded devices. So these are like the challenges. These challenges are there simply because of those technological improvements. Now you think, take your time and tell me, if you are to achieve these, maybe all of these are not suitable for every device that you create. I just made a list of few of them, identifying few devices. Okay? But if you are to create a device that can be sold in the current market, you need to equip these features with it, isn't it? To equip these features, what would you need? What changes you need to bring in the way you build your device to get these benefits? Normally what we do, embedded device means, maybe in the colleges would have done it. You design a board with 8-bit controller or a 16-bit controller, then have a C code written to it and then burn it and use it. That procedure anymore will not work, isn't it? It does not produce the results now. What should change? Which area of our approach should change? Should the hardware choice change? Or should the software choice change? Where do you think the change is required? Software, not in the hardware? Both. So complete change in approach is required to create products like this. And that's what all the companies are doing today. Alright, so all the companies are taking up new ways of designing products, new ways of implementing products to meet these challenges. So first step to understand what skills you need is this. If you understand this, then you will know the solutions. Right now they are using 10 solutions maybe. Tomorrow these 10 solutions will become 20 solutions. You will know how this whole thing will go and grow. In a couple of years, the technology that you may apply to solve these problems today may not apply that. You may apply something else. Okay? That's how the whole growth comes up. So as a user, as a student, what you need to understand is these things. Not just about design, writing some code, running it, seeing the outputs. That's not the objective, it will not serve us. Right? Let's look at now how we solve these problems, and how industry right now is solving things. If you want